Welcome back to my new video. This video, we are going to be talking about a very important um, area of large language models, and it has to do with mathematical operations and arithmetic reasoning. Okay, so let me create a markdown. This markdown, we're going to call it program aided language, also called PAL. Okay. And there's this paper here called Program Aided Large Language Model, sorry. And as you can see, it was written in January 2023. It says, well, large language models have recently demonstrated an impressive ability to perform arithmetic and symbolic reasoning tasks when provided with a few examples at test time, few short prompting. Okay. Much of this can be attributed to prompting methods such as chain of thought, which employ large language models for both understanding the problem description by decomposing it into steps. Okay, so this is a very nice paper by these guys from Carnegie Mellon University. So you can check it out. So I'm going to leave the link here if you are interested. Okay, so with this import, we can get started. Okay, so I'm just going to paste the import. Okay, so the first one that we are considering is PAL chain, which is the same as program aided language chain. And then as usual, we are going to import our openai. Once we do that, I'm going to paste openai class and then pass in these few parameters. Okay. And finally, we're going to consider the program aided language. So this is how you call it. Say PAL chain dot format underscore prompt, and then you pass in the large language model, and then the verbose is equal to true. Okay, now that you have access to the PAL chain object, I'm going to paste in a question, okay, a mathematical question that we'll see how it can be answered, okay. So the question is very simple, okay. Jane has 3 times the number of pets as Marcia. Marcia has 2 more pets than Cindy. If Cindy has 4 pets, how many total pets do the 3 have? So this is the question. So we want to ask our large language model to answer this question for us. Okay, these are more or less like a high school or college algebra, something very close. Okay, so let's see. So let's see. We want to print PAL underscore chain, and then we say run, and then we pass in the question. Okay. So that is all for PAL chain, program aided language. Okay, very, very simple API. You just need to import your OpenAI API keys, and then PAL chain from the chains module. Then you pass in the OpenAI as LLM, and then with PAL chain, you call from math prompt, then you pass in your LLM, and then you ask it the question. Okay, so let's run this and see what we'll get. I think I have to run this. Okay, I think I made a mistake with the question. Okay. You see, the final answer is 28. Okay, so let's see the thought process. It says what? It defined a def solution function, and then it created this as the as the so in Python, if I copy this and then put it here, you can see that this is a typical Python function with this doc. Okay, this is a doc, Python doc, and then it's passing in Cindy's pet, which was 4, and then it says, oh, Marcia has 2 more pets than Cindy, so he added +2. And then it says if Cindy has 4 pets, okay, so Cindy has 4 pets. See, and then now it says how many total pets do the 3 have? So you can see that Jane has 3 times the number of pets as Marcia, so it's 3 times the pet of Marcia, and Marcia is what? Cindy. Marcia also has 2 more pets than Cindy. Okay, so this is the thought process. So if you want to know the total pets, it's Cindy's pet, Marcia's pet, and Jane's pet, and then you add everything together. And once you run this, and then we call the solution function, you see, it should return 28 for us. Okay. So that is it. So you can see that the large language model was able to give the final answer as what? 28. Okay, so let's try another problem. This one is going to be a bit long, but we'll see the thought process of the large language model. Okay, so I'm going to paste that in, and then we can read through the question. So this one is more or less like a probability question. They say on a shelf there are 16 novels and 20 poetry books. Person A chooses a book at random off the shelf and leaves with it. Shortly after, person B chooses another book at random. Calculate the probability that the book selected by person B is a novel. 2. If it is known that the person B chose a novel, what is the probability that the book selected by person A was a poetry book? So this is more or less like a probability question. So this, you need to know some basic probability problem solving techniques before you can do this. So let's ask our large language model to give us a solution. So we're going to say LangChain, and then we pass in the prob. Okay. So I'm going to run this. Run that. So let's wait for LangChain to do its work. You see, it's done. So this is it created another function again. And if we copy that and then paste it here, you can actually see the doc, created a documentation for the question. And let's look at the thought process. It's a probability that the book selected by person B is a novel. It's a novel. You see, we have 16 novel books. There are 60 novels and 20 poetry books. So the total books is what? Novel plus poetry, which is 80 books. And it's a probability that the person selects a novel is novels divided by the total books. And the probability that the book selected by person A was a poetry. Now you have to calculate the probability for poetry is 20 divided by total books. And then the result, it says what? Probability that is a novel and probability that is a poetry. And then it returns the result. So if we call for solution, it says it's what, 0.75 and 0.25. Okay, so let's look at the, it said the question, and then let's see. So it gave the result as what? 0.75 as well as 0.25. So that is the result. So if we take the novel divided by 80 is what? 0.75. 0.75. And it's a poetry, it's going to be 20 divided by 80, which is 0.25. Okay. So that is the thought process of this large language model called PALS. Okay. So you can investigate more into this, and I think it's very interesting. So you can look more into it, and also you can check the academic paper. So if we look at the academic paper, you can see that there are more studies about, you can see Roger. Let's pose this question to the large language model and see what we are going to get. So I'm going to paste this one in and say, proba is equal to this. Okay. So the question is, Roger has 5 tennis balls. He buys 2 more cans of tennis ball. Each can have or each can have 3 tennis ball. How many tennis ball does he have now? Okay. So that's the question. So let's look at it, how large language model is going to understand power chain, and then we pass in prober. Okay. I think it's issue. Okay, so I think this should work. Okay, let's run this. So this is the thought process. Okay, so say Dennis initially has 5 balls and cans bought, and he buys 2 more cans of tennis balls. Okay, so it's 2 more, and each can have 3 tennis balls. So tennis balls per can is 3. So if you want to know the number of table tennis balls Roger has, is what? Tennis ball that he had initially plus the 2 that he bought times the tennis ball per can. Okay. So he bought 2 cans, and each can has 3 balls in there. So that is going to be 6 plus 5. So that is going to give us 11 balls. So you can see the result here is 11. Okay. So let's look at the academic paper and see what the answer is. So you can see the answer here is what? 11. Okay. Yeah, so basically that is what program-aided language models can do. Okay, so I hope you enjoyed this video. Don't forget to like, share, and subscribe. I'll see you in the next one.